Hello everyone, so today we are going to solve another interesting problem number 448. Find all numbers disappeared in an array. And this problem is a very practical problem. It could be used and applied at several instances on software engineering in day-to-day life. So the problem says we have been given an array nums of n integer where nums of I is in the range from 1 to n, and they want us to return an array of all the integers in the range 1 to n that do not appear in the number. So we have been given 4 3 2 7 8 2 3 1, and in this 5 and 6 are missing, so we'll return 5 and 6. Okay, and these are the constraints, and there is a follow-up. It is asking us to do without extra space and in O of runtime. Okay, so I'm going to show you two ways of doing this problem. One in which we'll be using extra space of O of n, and one without extra space. So the first approach is when the input modification is not allowed. So I am when we can not modify the input nums. Modification is not allowed. So what we'll do is, in this case, is we'll create one uh, temporary array called count, and in this will have the size of whatever the size of the original array plus 1, because we will be making this from index 0. So for index 0 I will define it as for 1, and for all other values I will initialize it at value 0. So the original nums that we have like this: 4 3 2 7 8 2 3 and 1. Then corresponding to it I will create, so this is of size 8, so I will create the count array of size 9. So this is 6 7 8 and 9. So what I will do is, now when I'm traversing the original array nums, I will update the values in the count of the numbers that we have seen in the original array nums. So let's say if I'm iterating the original array like this, so first I encountered 4, so what I will do is I will update 4 with 1 count because I've seen it for the one time. Similarly 3 I will update it with 1, 2 I will update it with 1 time, 7 I will update it with 1, so and 8 again will update it with 1 value. 2 we have seen it twice now, so we'll update 2 with 2. 3 we have seen it once more, so we'll update 3 once more with 3, and there is 1, we are encountering it for the first time, so we will have 1 as 1. So there are two 2's, and in the end we have also 1 8 that we have encountered, so that will also increment by 1. So in total we have 9 elements in the count array, and now we'll check whatever the indices, whatever the element in the count array has a count 0, then it means that those indexes are the missing numbers in the original array nums, so which are basically 5 and 6. So that will return. So this is the one approach of solving this problem. And another approach is if we want to do it in place. So approach 2 would be when input modification is allowed. So in that case, what we'll do is, we'll start placing this original numbers in the original array at their original position. So what I mean by this is the original nums that we have, and what we'll do is this is a one index array, so we'll shift all the values by one and start placing these number at their correct position. So this 4 should be placed at the index 3, because we are starting the numbers, because we have been given the original array nums from 1, so we'll shift by one value. So 4 should be placed at this, and we'll swap it with the 7. Similarly 3 should be positioned at the original position 2, so we'll again place 2 and swap 2 and 3. Now we'll do the same for everything. So doing this cyclically, what we'll do is we'll achieve these all these numbers which should be placed at their correct position. So like this, 7 and 8. And so at the end, we'll just now traverse this original array nums, and we'll see whatever number is not present in the original nums, and we'll update that value into our answer that we want to return. So these are the two approaches, and so the approach one has a time complexity of O of n and space complexity for the this counting approach is O of n, but the approach 2 has a time complexity of O of 1, because we are just cyclically placing the number at their correct position, and the space complexity for this is O of 1, because we are not using any step. So this approach 2 is for the follow-up question that we have been given. So now I'm going to write the two approaches one by one, and you can follow along with me for the on how we'll going to solve this problem. So this is going to be the approach one. Then the approach one, when the input modification is not allowed. So I will define one n variable which has the length of the whole nums, and I will define one count like this first, and I'm starting this from 0. So for that I'm taking one extra element, and now for every number in the original array nums, I want to increase the count of that number which I have seen. So by one, and in the end we'll return this I for I comma v in the from the count that we have created, and this we want to do if we have seen original if we have seen a value of 0. So to make it more clear, what I'm going to do is I'm going to print the count for here for you to see, and then we'll submit it later. So now let's run our code for the example test case. So you see this is the count array that we have created, and the values for 5 and 6 indices is 0, and we are capturing those indices and returning them. So now let's submit our code for this problem with this approach. So it has been accepted and it's running pretty fast. And now I'm going to show you the approach 2 for the follow-up problem, in which we are going to solve this problem in O of just n time complexity with O of 1 space complexity. So this approach is going to be like this. So I will define one variable I to keep the counter, and n would be the length of the nums, and we'll place the numbers at their correct positions. So what I will say is, like, while I is less than n, and I will define the position where this number at index I should be placed on, and I will compare it with the number at its index position and the number at the correct position if it has been placed, and if they both are not same, then I will swap them together. So nums of I, nums of position is equals to nums of position and then nums of I. So otherwise I'm just going to increment my I towards I plus 1. This is the case when we have seen the numbers and its correct position. The number at index I should be at its correct position. So now we can see by printing our original array nums. So this would have been sorted cyclically, and now we'll just traverse this. After this, we'll just traverse the list and we will capture the missing element. So like I said, the array has been sorted at its position, and now just we need to return the missing elements where uh, that are not present in the original original array nums. So that I will capture if nums of I is not equals to the I plus 1, because this is from one index and I is coming from 0. So to match those together, so now let's run it. So this has been also accepted. Now let's submit our code for all the test cases. So it has also been accepted. So that's how you solve this problem. I hope you guys are liking my solution. If you want me to solve any particular problem, please let me know, and please like and subscribe to the channel. It helps growing the channel, and it helps me in bringing more such awesome content for you guys. And I will see you tomorrow with another algorithmic approach to solve these problems. Thank you.